All right, let's go ahead and get started. Welcome to our Journey to the Cloud workshop. This is part 2 of our journey to the cloud, IBM Cloud Deployment 4 Ways. So if you weren't able to make our deep dive last week, I will be sharing the link for that as well. The link is also in the slides. So we have a combined deck. So all of the resources from part 1 and part 2 are in the same deck, and you can access those at the top of the chat. I also have here for you the IBM Cloud Signup link. So if you don't have an IBM Cloud account and you would like to follow along, there's a link to sign up for an IBM Cloud account there. I also have the link to the live stream. So the URL that you joined with today that you're currently watching the live stream on, you will be able to watch the recording after the event at the same URL you joined with today. Oh, actually, I already posted it. So if you're watching on YouTube or Twitch or Facebook, so if you head over to the Crowdcast link, which I'll show just a second in the slides as well. I have all of the resources in the chat too. So the live stream recording from part 1 is listed here as well in the chat. Let's see. Someone asked, is this the same content as on 623? Yes and no. So last week we did a deep dive of cloud deployment models, IaaS, PaaS, CaaS, and FaaS. So we went over 4 different cloud deployment models. And today what we're going to be doing is showing you how to implement some of those solutions with IBM Cloud products and offerings. So this is more of a continuation of what we went over last week. Let me move this over a little. There we go. Okay. So thank you all so much for sharing where you're from. It looks like we have people from all over. We have some Michiganders. We have some people from Texas, California, New York, Uruguay. We have some people from Colombia, New Jersey. Very cool. So if you would like, we're going to introduce ourselves. So I will introduce myself. I also have a teammate of mine with the Call for Code team who's going to talk to you a little bit about that today before we get in and get our hands dirty. So we will be introducing ourselves kind of using this format. So if you'd like to introduce yourself so that you can get better acquainted with us or meet others that are, you know, currently joining from different locations, get to know each other better, feel free to share. So your name and pronouns, your title and company, or maybe a program, what program you're currently studying, where you're from or where you're joining from during quarantine, something you love, and a quirk. So something that's uniquely weird or different about you. So while you're working on that, I'm going to go over just a few pieces of housekeeping. So as I mentioned before, the links are available to you. Feel free to leave comments. This is V1 of this series. So there will be updates and changes as we go, adding in some more things for you. So feel free to leave comments in the slides of maybe some things you'd like to see, some technologies you'd like to see. I'm always interested to see what tech stack you all and technologies you all are working in. So feel free to comment in the chat as well. Again, this is the Crowdcast link that you joined with today. This will automatically convert into a live stream recording at the end. So you'll be able to view the playback here. And again, if you would like to follow along, you can sign up for an IBM Cloud account. It is free. We have over 40 products and services that we have free light tier services for. So you won't start getting charged at any point in time. So I'll introduce myself first. So my name is Jenna. My pronouns are she, her. I am a cloud developer advocate with IBM. I am from and currently joining from Detroit, Michigan. I've been working with IBM in Austin for the last few years, and I currently join the New York City team. But we're all kind of one big spread out North America team now. So for now, I'm just kind of hopping around. Something I love are my dogs. Luckily, they are relaxed and quiet at the moment. We'll see how long that lasts. I have 2 Yorkies. They are old, but have not gotten any slower or less annoying, which is great for me. So, and a quirk. So I always go with Old Faithful. I have an obsession with tuna melts. It is a serious problem. I shouldn't eat as much tuna as I do. So tuna salad and tuna melts sandwiches. And I judge an entire restaurant and everything on the menu based on how well or horrible they're willing to put love into making a good tuna sandwich. So if you have any recommendations, throw them in the chat. I've been looking for some places, especially because some of my favorite places are closed now. So hopefully some new ones will open back up. So I'm going to pass things over to Upkar so he can introduce himself and talk to you a little bit more about call for code and lots of cool stuff.
All right, thank you, Jenna. So hey everyone, my name is Upkar. Later, I'm the tech lead for Call for Code for Racial Justice Projects, work in the Call for Code team, and very interested in lately in everything cloud native. A lot of projects that I work on use solutions like Code Engine, Kubernetes, and Serverless, and things like that that Jenna talked about last time, and hopefully we'll get to show you a few of those today. I go with he and him, and I love photography. If that was one thing I could I could tell you about myself. I don't know about the unique stuff, Jenna. I'll pass for now. Maybe next time I'll come back to it, if that's okay. All right. So speaking of Call for Code, thank you. You read my mind. So Call for Code is our annual hackathon, so to speak. We launched it in 2018, and we asked 24 million developers across the world to take on big challenges. So challenges like climate change, natural disasters, etc. We've had an amazing response, as you can see on the slide here. There's 400,000 plus people from over 179 countries took part in the challenge, and they've created more than 15,000 applications using different technologies and frameworks, ranging from IoT applications, using weather data, mobile apps, and of course, the more traditional web applications on cloud. So we launched, on the next slide, Jenna, we launched the 2021 challenge at the end of March. Thank you. Oh, it's still loading on my side. All right, so we launched 2021 challenge at the end of March. It is still going on. The submission deadline is end of July, so you do have a month to take the challenge. We have 3 themes this year: the zero hunger, clean water and sanitation, and responsible production and green consumption. So as you can tell, there's they're really large themes that you can build a lot of stuff around. You can find more about the themes as well as the challenge on developer.ibm.com/call for code. Once you join there, you'll also be taken to our Slack workspace, and I hang out there. Last time, I think I said this, Amr came and said hi. So it's nice of you, Amr. If anybody wants to talk tech, you can find me there. So what do you win if you take part in this challenge and you're a winner? Jenna, next slide. All right, so the grand prize is $200,000. It's a lot of money, and we also have first runner-up, second, third runner-up prices as well. But apart from the cash prize, you also get to work with some amazing IBMers, some senior IBMers developer advocates, data scientists along the way, right? So there's a lot of value there. Equally important, this challenge is a way to grow your skill set, be a part of the community, and bring your amazing ideas to action while also doing social good. We have, like I said, on the Slack channel, we have over 20,000 members. So you can, ideate or talk about technology with that community. All right, Jenna. All right, I'll pass it back to you.
All right, thank you so much. I was muting myself, trying to get rid of that echo we had last time. Okay, so before we get started, I just wanted to touch on a few things. So IBM Cloud Certifications, what are they, right? So IBM has a lot of amazing free resources. Here we go. So I've picked out a number of certifications for you that I've personally taken that I think are really great. They are free. It's not like some of the other courses that you can take the course for free, but you have to pay for the certification. It is 100% free. You earn badges at the end of each course that you take. So these are some really great badges that I think for any developer to really get some foundational understanding of all things cloud microservices, cloud applications, cloud native development, things like that, and really get you a foundation so you can not only start getting your hands dirty and start building, but really understand all the things that you're doing. I think a lot of times as developers, we do a lot of cool stuff, but we don't actually know what we're doing. We just have the final result. So this is a really nice way to really understand the different pieces, what's going on, why we're doing things this way. So the first badge I have here for you is the IBM Cloud Essentials badge. So this will allow you to relate how IBM Cloud enables different service models, IaaS, PaaS, SaaS. So there's all these acronyms, that we throw around a lot. So one of the things that I like to do is make sure that I'm constantly using the acronyms in their full terms so that we all can understand them. So we're going to talk about them a little bit. So just to start, IaaS is infrastructure as a service, PaaS is platform as a service, and SaaS as software as a service. And these are service models. And we also have public, hybrid, and private deployment models. And these are all different models of cloud computing. So you'll learn how to access IBM Cloud using different tools, discover IBM Cloud products and services available for different functionalities, and you'll be able to really communicate different ways that IBM Cloud delivers services to developers and operational teams. So it'll give you a nice summary of core groups of services that are available. So the next one, so this is where things can start to get exciting for me, at least. So this is going to allow you to demonstrate through projects, hands-on understanding of cloud essentials, design thinking, agile development practices, and DevOps. So you'll be able to develop cloud-native applications using different IBM Cloud offerings, like platform as a service, containers as a service, and in different programming languages like Java, Node.js, and frameworks like Spring, Cloud, Netflix, OSS, Console, for just a few examples. So you'll be able to take what you've learned from design thinking and leverage that to, with different IBM Cloud Innovate and IBM garage method practices, which are really cool. Different techniques and work through the overall development lifecycle. So cloud native is, you know, all the buzz now. This badge has been around for a while. I actually did this badge a couple years ago. So this is going to be able to allow you to take all of that knowledge that you just learned from cloud development essentials and cloud application development essentials, and apply that knowledge to cloud native application development. So you'll follow the 12-factor app parameters and the characteristics of a scalable and resilient cloud application that allow you to deliver cloud native application development engagements. So you'll be using Java, Node, Python, container configuration and development, the DevOps toolchain, Agile, and test-driven development using JUnit, Mocha, a few other ones. So yeah. The next one I have is Cloud Course. This is like a newer-ish one, newer-ish to me. It wasn't, I didn't see it when I was doing a lot of badging. So this is going to allow you to understand the basics of cloud technology, and you'll be able to get really familiar with describing different cloud platforms and different models, cloud deployment models, including infrastructure as a service, platform as a service, software as a service, and then public, private, and hybrid multi-cloud models. You'll be familiar with cloud application terms like virtualization, VMs, containers, object storage, microservices, serverless, cloud native, and DevOps. Excuse me. So this one, you'll be provisioning different services and getting really hands-on with a lot of these things. This one's really cool. So this is a Docker Essentials badge. So this is going to, if you're not familiar with Docker, this is going to give you a nice intro, walkthrough, show you how to run containers from Docker Hub, create Docker containers, solve basic problems of orchestration like reconciliation, scaling, high availability, and service discovery. And then you'll understand best practices for using Docker files and the basics of how to use tools such as IBM Cloud Kubernetes Service that you'll be able to leverage your Docker skills with running your container images on IBM Cloud Kubernetes Service. And then the last one here, sorry, the picture's so bad. The picture was very tiny. So I decided to go with a fuzzy one rather than no picture. So this is an open source foundations badge. So this is going to allow you to understand what an open source project is, how to use common open source tools. It'll help you find and contribute to open source projects. And it'll allow you to be able to create and lead an open source project. So for all things open source, this is a really great resource to get you all started. So let's go ahead and get started. Let's go here. Okay, so this is going to be part 2. So we covered a lot last session. We're going to just briefly touch on some of the important pieces we need to be familiar with for this session. Okay, so first thing we're going to do is take a look at cloud deployment 4 ways. You know, what does that look like? You know, we've heard a bunch of acronyms and heard a bunch of words thrown around. You know, what does this actually mean? So first thing we're going to do is compare different compute options. So newcomers to cloud computing can be a bit put off by the large number of acronyms in use, as we've already seen, and there's a lot more. So just about everything is sold as a service these days. To try and clarify some of the available offerings, we're going to take a look at some of the acronyms, namely infrastructure as a service, platform as a service, containers as a service, and serverless, which is also known as functions as a service. So when trying to decide which of the offerings is most suited to you, one way to look at it, which isn't necessarily the most helpful way, is how much money do you have to spend. So when we're talking about IaaS, we're talking about things like VMs, IBM Cloud's virtual server for virtual private cloud. So when you're working with things like virtualization and virtual machines, this is going to really give you the most control. It's going to allow you to, from an infrastructure standpoint, be a lot more hands-on and customizing very specific pieces of your infrastructure. Probably not the best solution for developers, for application developers. The next we have here is containers as a service. So whereas with infrastructure as a service, you can leverage existing languages and tools. You can run it on, you know, various operating systems, but it requires a little more work for you if you're, you know, working with a virtual machine. Containers as a service are really nice because they give you the maximum portability. So you're able to run them on different operating systems. You're able to run different images. You're able to work with a team across various operating systems seamlessly. It's really nice. And what's nice is it allows you some customization to the underlying infrastructure, but it doesn't require as much work as, for instance, a virtual machine would, especially with like IBM Cloud, Kubernetes as a service. A lot of those things are taken care of for you. You don't necessarily need to manually set things up. Next option we have is platform as a service. So that's going to be things like Cloud Foundry. We're going to take a look at IBM Cloud Kubernetes as a service that we provide as a PaaS solution. We also have Red Hat OpenShift. That's a platform as a service offering we have as well. So this is going to give you a mix of developer speed and control. So this is going to give you, still give you a good amount of control, but it's going to allow you a lot more speed to get up and running and get to the development pieces that are the most important, you know, parts of your job as a developer. You don't have to mess as much with the underlying infrastructure. And then the last option we have here is function as a service, also known as serverless. So this is going to give you the maximum development speed. So this is going to allow you to get up and running seamlessly, instantaneously. You don't have to worry about orchestration or getting clusters, pushing to clusters. You don't have to worry about all of those pieces. All of that is done under the hood for you. We'll take a look at that with our code engine. That is our function as a service offering that we have. So we will take a look at that. So what we're going to do is first things first. We need to set up our dev environment. So what does that mean in context here? Now, you can get as much as you would like. This is kind of like a pick your flavor. So what we're going to do for today's workshop is we're all going to work in the IBM Cloud Shell, which I will show you. But the one thing you will need is an IBM Cloud account. So you can sign up for an IBM Cloud account with the URL here. It's also at the top of the chat. And so what we're going to do is we are going to work out of the IBM Cloud Shell. If you would like to get everything set up locally, excuse me, on your local device, I do have the steps to do that as well. So if you would like to do that, feel free to take a look at the slides. We're going to skip them for purposes of this presentation, but they are there. So if you want to set things up locally, it's going to take a little more time, but you can follow along in the slides for that. So what you're going to need is an IBM Cloud free light tier account. Again, it's completely free to use. We have over 40 light plan services for things like application development, analytics, AI and machine learning. You know, if you want to build something in Watson Studio, if you want to build a chatbot, you know, there's a lot of things you can do. If you want to add security with App ID to your application, there is a free light tier for all of these things. And you won't start getting charged at any point in time. What'll happen is once if you get to the point where you're using more provisioning than you're allotted, then it'll ask you, if you want to upgrade, your services, or you'll need to, delete some things so that you're within your limits. But you still have access to the full catalog, IBM Cloud Catalog. So if you upgrade your account or need to at any point in time, you'll get access to over 190 unique offerings. And there's a whole bunch of different credits. So if you're looking to upgrade at any point in time, there's a lot of credits, as you'll see as we walked through this, for you to get. So if you would like to, and this is going to be the last part of the workshop, but if you would like to follow along with IBM Cloud Code Engine, which I would highly, highly recommend, it is definitely the quickest get up and going option. You will need to upgrade your light tier account to a pay-as-you-go account. So there is an always free tier. So you get 100,000 vCPU seconds per month. You get 200,000 gigabyte seconds per month, and you get 100,000 HTTP requests per month. So that's in the always free tier. So just because you're upgrading to a pay-as-you-go account does not mean you're going to get charged for the pay-as-you-go account. It does allow for quite a bit. My understanding is with all of the stuff going on recently around crypto mining, this is a kind of a protector to keep from things getting abused. So, but again, and you'll be able to see how much you're using and everything anyway. So you don't have to worry about getting a charge from Code Engine. It's just required for the account. So let's build something. So I want to preface this. So for the first section, we're going to cover infrastructure as a service. I'm going to just show you what this looks like. These are our virtual private cloud, our IBM Cloud Virtual Server for virtual private cloud, and our bare metal and virtual servers offerings do not have a light tier. So I'm going to just demo this. So don't feel like you need to, create any instances of anything. You would need to delete them all. But I just want to show you, what does this look like? What do these things do? Once we get to our containers as a service and our platform as a service, I will show you how to spin up instances with our free light tier. Here we go. With our free light tiers of everything. So infrastructure as a service, so I'm going to just give a high-level overview. We're not going to go as in-depth as we did last time, but so infrastructure as a service is a type of cloud computing. It lets you allocate your compute, network, storage, and security resources on demand, right? So it gives you a lot of control. The IBM Cloud approach to IaaS lets you scale and shrink resources as needed around the world in more than 60 of our data centers. And you'll be able to see that when we get into the portal here. You'll get access to the full stack of compute down to the bare metal. So we'll be able to take a look at the servers. You'll get a lot more control. You can customize hardware to your exact specifications to meet any of the demands you have of your workload. There we go. So our IBM Cloud infrastructure as a service offerings are, as I mentioned before, IBM Cloud Virtual Server for Virtual Private Cloud, and then our classic infrastructure. We have Virtual Private Cloud and classic infrastructure. So for our virtual private server, we have our IBM Cloud Virtual Server, and then for classic infrastructure, we have bare metal. We have bare metal and virtual servers. So this is what it looks like here. So what I'm going to do is, let's see. Yeah, let me, oh, okay. So as you can see, we have a lot of stuff going on here. So with our virtual private cloud infrastructure, we have virtual server instances, dedicated hosts, you have your different SSH keys, custom images. For our infrastructure network, we have VPCs, subnets, floating IPs, public gateways, virtual private endpoint gateways. You have an access control lists, security groups, routing tables, VPN gateways, load balancers, and flow logs. So this is a lot of stuff that as a developer you don't necessarily worry about or pay attention to. But if these are things that you need to customize and have a lot of control over, you know, this will definitely allow you to do that. So for storage, we have block storage volumes and block storage snapshots. And then we have auto-scaling instance groups and templates. So this is a nice getting started with everything. So I'm going to just show you here what this looks like. So from your dashboard, you would search for VPC, and you would click on a virtual server for virtual private cloud, VPC there. Now, if you're creating a new virtual server for VPC instance, you'll need to give it a name. You don't really need to do anything else. The resource group should be default, especially if you don't have, if you haven't created other resource groups or you're not working with teams, or from a work account, it'll automatically be set to default. So these are some of the data centers that we're talking about, right? So each of these locations has different data centers available. Oops. It's automatically default to Frankfurt 2. So it also automatically defaults to a public multi-tenant virtual server. You can also select to have a dedicated single tenant virtual server if you'd like. So the other thing you're going to do is you're going to select your instance's operating system and version from an image or snapshot. So we have CentOS, Debian, Red Hat Enterprise Linux, Ubuntu Linux, Windows Server, and then we have custom image and catalog image here as well to choose from. And those are from the images. You can also upload a snapshot. So the only other thing you'll need to do other than give it a name and select, you know, your configurations is you'll need to add an SSH key. I have a note in the slide of, you know, where to find your SSH key locally. There's also some, if you click new key, you can create a new one, and there's some resources to do that as well. You have your boot volume here. We don't have any data volumes yet, but we can create some. And then for networking, we have the default virtual private cloud networking. And then we have some networking interfaces here. with a default security group. And then, as I mentioned, there's lots of, so for instance, you're in here now with your free light tier account, but there's, you know, if you need to do anything at any point in time, there's always like coupons and things. They can give you discounts for everything. So this was one that I found. It just shows the different pricing plans for virtual server for vPC, your block storage, your load balancer, VPN, and virtual private cloud. So it's pretty simple. It's all in one place. And then again, I just showed here how to add an SSH key. So I just gave it a name. Check for an existing key in a file. Well, it doesn't really give you the command to do that. I gave you the command to do that in the slide. You're going to put a cat with a squiggly and a / before that in your local terminal, and that'll show you if you have an existing SSH key. And if not, you can always create a new one. There's some docs to do that. And then what you're going to do is, I blocked it out, but you're going to put your key in here. And then it also gives you, one thing that's really nice is there's a lot of code snippets and code samples everywhere. So this, when we add our SSH key, now I'm able to create a virtual server instance, and I'm able to get a sample API call. So it's automatically generated for you with all of your cloud endpoint, your authorization token, your user agent. It's got all this stuff here. So so this is showing you the REST API request for your settings. The only thing left you need to do is generate an IAM token, and then there's resources to get started with the REST API. Sorry, my dogs are cranky. Okay, and then when you've created your virtual server instance for virtual private cloud, you can access that and check it out here. There's all kinds of stuff here. So again, this is our compute virtual server instance here that I just created, but you can access your SSH keys, your dedicated hosts, your subnets. There's a lot of cool stuff in here. Where did I go? Let me see. Oops. I think we got some, okay, we had some duplicate slides. That's okay. Let's see. And then we need to, okay. So the next thing we're going to take a look at is bare metal. So again, if you're not, you know, I know a lot of engineers personally that work in cloud infrastructure, and these are a lot, you know, things that they're concerned about, and a lot of DevOps roles, you know, building dashboards to monitor a lot of these things for SRE teams, things like that. So if you search for bare metal server, right? So this is going to give you, you know, on-demand, processor-intensive, and disk IO-intensive workloads. So again, I didn't have to add anything here. It already created a host name. The default is monthly billing. Again, we can choose our operating systems here. We have CentOS, Citrix, Debian, Microsoft, Red Hat, VMware, Ubuntu, and then no operating system. And then you can, it has default storage disks. So you've one of 4 used. You can add new ones. You can add file and block storage. It has public and private network interface included. That's automatically the recommended network interface. If you look at the bottom here, you can also add a private VLAN that will be auto-assigned. And there's some add-ons, so power supply, IBM Cloud Backup, server security, things like that. Firewall, monitoring, host ping, remote management, things like that. So This is like really getting into the weeds of infrastructure that as application developers, we don't normally have to worry about, right? There's usually a infrastructure team and DevOps team and, you know, people to worry about a lot of these pieces. So you're just not mindlessly, you know, provisioning things and using resources that you don't necessarily need, right? So this gives you a lot of control, requires, you know, a bit more work. IP addresses, VPN management, things like that. So, yeah, so a bit more expensive. So some pros to infrastructure as a service, or IaaS. So what are some good things about, you know, infrastructure as a service offerings, right? Like virtual private server and bare metal, IBM Cloud, virtual private server and bare metal. So it allows you to accelerate performance. You can deploy an IaaS bare metal server, a virtual server, or both in a matter of minutes, which is really nice. You can do it all from one space. You can integrate with your systems. You can take advantage of other IBM offerings and services being integrated to optimize your performance. You can employ enterprise-grade hardware, so you're able to select from more than bare metal and virtual, including SAP certified infrastructure. And then you can extend your on-prem data centers. So you can create, deploy, and manage servers on their own or in a hybrid cloud. So next thing we're going to look at here is containers as a service. So what we're going to do is we're going to talk a little about containers as a service, and then we're going to take a look at actually our IBM platform as a service offering for containers, which we have IBM Cloud Kubernetes as a service. So that's our platform as a service offering. So when we're talking about containers as a service, we're talking about, you know, Docker Swarm or Kubernetes, right? Here we go. So containers are really ideal for application modernization and hybrid multi-cloud scenarios because they're lightweight and portable. And with container services from IBM, they're built on open source technologies like Kubernetes, and you can facilitate and accelerate your journey to the cloud. So you can use continuous integration and continuous delivery, CI/CD tools to build and deploy your containerized applications in the cloud. So you can orchestrate your containers with a managed Red Hat OpenShift or IBM Cloud Kubernetes service and address most of your transformation needs with containerized IBM middleware and open source components found in our IBM Cloud Packs solutions. So when we're referring to containers as a service in general, we're again talking about things like Docker Swarm, Kubernetes. Our containers as a service offering for IBM that we have are our IBM Cloud Packs. So we have IBM Cloud Packs for a number of things. So we have IBM Cloud Packs for data, business automation, Watson AI Ops integration, network automation, and security. So these are a bundle, a package of service offerings for each type of containerized need that you have. So for instance, you know, if you're looking to provision a containerized Watson AI Ops application, right? And there's a lot of pieces that are included in building out a solution like that, right? So IBM Cloud Packs for Watson AI Ops will include a number of different pieces that will all be orchestrated together and seamlessly integrated together to give you that type of solution. So IBM Cloud Packs are packaged and bundled solutions for you in a number of areas, and these are the areas we have. So again, the data, business automation, Watson AI Ops integration, network automation, and security. So here we go. for data. Oh, sorry. And this is something too that I think would be good to explore, the different cloud packs. We definitely don't have enough time to explore them in today's session. We could probably spend a good hour just exploring the different cloud packs. But I have all of the resources in the slides as well if you want to take a look and start playing around with those as well. So some benefits to containers as a service, deployment model. So it's portable. So when an application is created in a container, the completed application has everything it needs to run, right? So, you know, when we have container images, we run them as containers. They have all of the dependencies, everything they need, configuration files. So having that portability allows end users to reliably launch the applications in different environments, whether it's a public or private cloud. It also grants enterprises a large amount of flexibility, and it accelerates the development process and makes it easier to switch to a different provider or cloud environment, right? It's really portable. So if you make a change, you know, this is a better option. It's really easy to move things real easily to another operating system, another cloud. Let's say you have public or private. You want a more hybrid cloud model. It allows you to your applications a lot more portable, easily make those changes. So it's highly efficient and cost cutting. So containers don't need a separate operating system, and they require less resources than a virtual machine. A container often requires only a few dozen megabytes to run. It allows you to run several containers on a single server that would otherwise be used to run a VM. So this efficiency is coupled with higher utilization levels regarding the underlying hardware. And all of this just helps reduce data center costs and bare metal costs. It's just really overall just reducing those costs. Containers don't interact and are somewhat isolated from other containers on the same servers, although they do share all of the same resources. So if an application crashes for one container, other containers can continue to use it without experiencing any technical difficulties. So you don't have to worry about this container crashed, everything's down, no one can do anything, we're all stuck, it's a nightmare. Other containers can continue using the same resources without experiencing any of those technical problems. So it's also secure. So isolating containers from one another doubles as a risk minimizing security feature. So if one application is compromised, then the negative effects of that compromise aren't going to spread to other containers, right? So one is compromised, the other aren't going to be compromised. It's also simpler to manage your hosting system. So you can quickly launch updates and security patches because containers run application processes in isolation from the operating system. So they don't need specific software to run applications. So it allows you to quickly launch updates and security patches. So speed. So since they don't need an operating system book, it takes seconds to create, start, replicate, or destroy a container. It enables quick development process, expedites the time to market and operational speed, and makes releasing new versions or software simple, speedier, and a lot easier. So this helps with the customer experience also, right, by enabling enterprises and developers to quickly respond to bugs and incorporate new features much sooner. So last pieces here, we have scaling. So containers feature the capability for horizontal scaling, and that allows end users to incorporate multiple identical containers within the same cluster to scale out. So by using smart scaling and running only the containers that you need when you need them, you can dramatically reduce costs and boost your return on investment. And then the last piece, which for developers, this is really nice, is streamline development. So Having an effective and efficient development pipeline is an advantage of a container-based infrastructure because they allow applications to work and run as if they were built locally. So the environment inconsistencies that you have normally with local development are completely eliminated. So removing any of these environmental inconsistency is going to streamline testing and debugging, and it's also going to double for updating applications. It's only going to require the developer to take a few moments or modify the configuration file and then just generate new containers and delete any of the previous ones. So next thing we're going to look at here. So this is where we're going to really get into some stuff. So platform as a service. So IBM's platform as a service offerings are IBM Cloud Foundry, IBM Cloud Kubernetes Service, Red Hat OpenShift on IBM Cloud. So these are things that I'm going to introduce you to today, show you how to get set up, and then I have some resources for tutorials for you to work on. They also, like for instance, the IBM Cloud Kubernetes Service labs lead to IBM Cloud Kubernetes certification. So I'd highly, highly recommend. I'm probably going to do that this weekend. But before we jump in, so a platform as a service, or PaaS, is a cloud computing model that provides customers a complete platform, including hardware, software, and infrastructure. So you remember all those pieces that we just looked at with VPC and bare metal, and you're like, what is all this stuff? I mean, that's what I was thinking. So those are all things that you don't have to worry about with a platform as a service. So for developing, running, and managing applications, this is a complete platform that includes the hardware, software, and infrastructure pieces for you. And you can manage applications without the cost, the complexity, and inflexibility of building and maintaining that platform on premises. So you may have heard like on-prem, right? So these are infrastructure services that are managed on premises, right? Like if you have a server room. So this allows you to take care of those pieces of your application without needing to have a server room out back, right? And the two infrastructure guys that are the only guys that know what's going on back there. Just takes care of that for you. The platform as a service provider hosts everything: the servers, the networks, the storage, operating system software, and databases at their data center. So within our global IBM Cloud data centers. So then the customer is able to use all of it for just a monthly fee, and it's based on usage. So you can purchase more resources on demand as you need them. And this lets your development teams build, test, deploy, maintain, update, and scale applications much more quickly and less expensively than they could if you had to build out and manage your own on-premises platform. Okay, here we go. Okay, so I'm going to show you here how to, let's see, how to deploy to IBM Cloud Foundry. Let me, all right. Okay, so let me share. See if you can all see this. Okay, let me reshare so you can see. Window, Chrome tab. Okay, cool. Okay, so the first thing we're going to do, so if you have your IBM Cloud account handy and you've logged in, you can go ahead and search for Cloud Foundry. Give it a second. I think my internet is, you know, doing some things. Let me refresh this real quick. Wants me to relog in. Okay. All right, cool. So the first thing we're going to do is search for Cloud Foundry. See here, we have our Cloud Foundry service. So you can go ahead and click on that. Okay. All right. So as you see here, we have, so this is a public, IBM Cloud Foundry public. As you can see, we don't have any applications or services yet. This you can see here, you can deploy and run your applications without managing service or clusters with Cloud Foundry. So as you can see, so this was our option between our containers as a service and our serverless options, right? So you don't need to worry about clusters or orchestration, but it's not going to be as quick and seamless as something like serverless. So it's going to automatically turn your source code into containers. It's going to scale them on demand, and it's going to manage the user access and capacity. So what we're going to do is we're going to scroll down here. So with Cloud Foundry, we have access control, automatic health management. So crashing applications are going to restart automatically. Automatic placement, applications are automatically placed across multiple data centers. So you don't have to, remember when we were looking at data centers, you don't have to, you know, you don't have to spread your applications across different data centers manually and load balance and do all of those things manually. And then automatic routing. So the internet reachable routes are automatically going to be created for your application. And what's really nice about access control is that you'll have really finite assignment and dispensing of compute capacity to development teams. So you don't have to worry as much about resource waste. It supports all of these application runtimes. So if you're a Ruby developer, you know, you're working in Go, PHP. So these are all of the things, all of the application runtimes that Cloud Foundry supports. There's a lot of documentation here too. So what we're going to do is we're going to create a new Cloud Foundry application. Okay. Okay. So, okay, so we can just leave our location in Dallas. As you can see, you can select different regions here. I'm going to just leave it as Dallas. Oh, this is Java. JK. Okay. So what I want us to do, and it opened up a new tab. So just go back to the last tab. What I want us to do is go down to the runtimes and click on the SDK for Node.js. We're going to deploy a Node application to Cloud Foundry. So what this is going to do is this is going to create a Cloud Foundry sample application for you. Okay, it's the default. All right. Now my page may look a little different than yours because I have this, I have my account upgraded so that I can use Code Engine. Yeah, so this is the monthly price, but again, this is part of our light tier services. So You know, unless you're building a, you know, Amazon system clone, you're not going to be, you know, getting crazy charges. You shouldn't be getting any charges with the free tier. So anyway, you can configure your service. We have the SDK for Node.js here. I'm going to just call this, you know, my Cloud Foundry app. Okay. Automatically has a domain here for us, organization. So I have more than one. It should just be your email and a dev space. I have more than one resource group for some reason. I think I created it for something else. Okay, so that's it. We just gave it a name, made sure our Node.js was selected, and it made the app name the host name. So that's easy to remember. And then we can just click create. Just give it a second. All right, so it is, as you can see, it's starting here. We're going to just give it a second. So it's deploying our app to Cloud, the sample app to Cloud Foundry. So as you can see here, it says, congratulations, you deployed a Hello World sample app on IBM Cloud. To get started, follow the step-by-step guide or download the sample code. So you can download and start working on your app locally and push your changes, and it's all deployed and ready to go. And you can add and change and do whatever you want to it. In the tutorial that it has here, it will show you how to also integrate other IBM Cloud database service to your application. So as you can see, you don't have to go anywhere. It's all here. So if you don't know how to clone the project and run it locally, it shows you how to do that. So you're going to clone it, cd into your project. Since it's a Node application, you're going to npm install and start the application, right? So this shows you how to do all this stuff locally. So cool. So as you can see here, it went from starting to running. So our Cloud Foundry application is running. It is deployed. It is live. It took like less than a minute. As you can see here, we can visit the app URL. And here is here's our application. So it has some UI. It has the infrastructure pieces in the back end, a little Node.js starter application, microservice for you. So if you want, you can just go in and use this and just change the UI and use it for something. Or as you can see here, you can add an IBM Cloud database and, you know, add a backend and, or, you know, add some CRUD routes and start making, you know, API requests somewhere to, you know, you maybe want to add a Google Maps to it, or, you know, want to add a, you know, Mapbox map and start doing something with that. The other thing I want to show you is this auto scaling here. Now, this is something that we're going to look at a little bit more with Code Engine. Policy. I'll do that. Oh, okay. So this allows you to create an auto-scaling policy. So as you can see here, you can set default instance limits. So the maximum instance count. So this is setting the minimum instance count. Sorry, minimum instance count. Minimum instance of your Cloud Foundry application. This is setting the maximum number of instances for this application. And then you can set different scaling rules too. So these are default here. So if average memory used exceeds 80 megabytes for 120 seconds, then increase one instance and then a cooldown period of 300 seconds. So This allows you to auto scale, but it requires some work, right? It requires you setting the rules of, you know, we're going to scale up and add an instance, we're going to scale down and remove one. It requires some manual work. What we're going to take a look at with Code Engine is that it completely takes care of all of those things for you. And we'll see that in just a second. So the other thing that I want to show you next here is our IBM Cloud Kubernetes Service. So this is our container as a service. This is IBM's platform as a service option, right? So Kubernetes, standalone Kubernetes is a containers as a service option. We have IBM Cloud Kubernetes as a service, platform as a service offering. Let's leave this. Excuse me. So I just want to show you. So you don't have to worry about this. If you look at the slides, actually, what I have here. So I wanted to show you this, so I had to create a cluster earlier because it takes a little bit of time. So okay, so what did we just see? We just saw deploying to Cloud Foundry. It was pretty simple, right? Pretty quick. But auto scaling, like let's say you deploy your application and you get 100,000 people that are, you know, sending requests to your application to use it. And you don't have auto scaling policies set up for that, right? Those are things that you have to manually worry about. What you can do here with Kubernetes Service, as you can see here, there's a free, this is your free tier. So again, I already created this earlier, which is why you're seeing a price for me going back in, because I'm trying to like create another cluster. But you are allotted one free Kubernetes cluster. It's free for 30 days, and then after 30 days, it will automatically get deleted. So you get one free worker node with 2 vCPUs, 4 gigs of RAM, and it's free. So, you know, you can spin it up again after 30 days if you want, after it's been deleted. So as you can see here, we have the Kubernetes orchestration service. I give my cluster a name. And then let me take you in to take a look. So if you ever get lost or you're not sure where to go, just click IBM Cloud and it's going to take you back to your dashboard. So we have a lot of quick start stuff. I love quick start stuff. For instance, create a Kubernetes cluster. So we just did that. So I can just click on my cluster here. So my resource list, which you can also access right here, second part on the list, is my cluster free. So this is my cluster that I created earlier. So again, feel free to create a cluster. It is going to take some time to get it up and running. So it's not going to be as quick as Cloud Foundry. It is going to take a little bit of time to get up and running. However, it is going to allow for some of that auto scaling orchestration where you excuse me, don't have to be as hands-on as setting policies, right? So Kubernetes is going to take care of some of that auto scaling for you. It does, like I said, take a little bit to spin up. What's nice here is we have a few things here. So if you click this help button, we have a few things here. So this shows you how to log into your cluster. So if you click log into your cluster and you click the IBM Cloud Shell, it's going to open that up for you. And then what we're going to do is we're going to set the context for our cluster in the Cloud Shell. So like I mentioned before, if you would like to play around with all of this stuff and not have the headache of setting up things locally, on your local computer, you can do all of this within the IBM Cloud Shell, and everything is already installed in here for you. So as you can see here, so it has my account, my Cloud Shell. So if I type IBM Cloud, I can use the IBM Cloud CLI. This is going to allow me to use, all of the things, everything I need to use any IBM Cloud offering or services, Kubernetes, OpenShift. It's all in here, ready to go, good to go. So what next thing I'm going to do is I'm going to copy this cluster configuration, okay? And then I'm going to paste it in here. Actually, let me move this up for you all. You can see a little better. Let me make this a little bigger so it's easier for you to see. There we go. Okay. There we go. So I'm going to paste this right here, which I got from my cluster here. Cool. So it says the configuration was downloaded successfully, added context for my cluster to the current kube config file. I can now execute kubectl commands, kubectl, whatever works for you. We'll just say that. So what we can do here is we can run kubectl get nodes. I don't know where the end of that word went. It's so odd. Maybe I didn't, oh. That's so, okay, so it just doesn't like, it copy and paste it wrong. But if you do kubectl get nodes, let me just, okay. Here we go. So as you can see here, status is ready. We just, I created it earlier. Has the IBM Kubernetes Service version. Got all of our information here. This is a little big now, but that's okay. As you can click here, you can deploy your app. So you can set up your image registry. This is something that we're going to plan to do in a part 3, where we're going to really get in. We're going to go in and show you how to set up your image registry, create images that then you can then deploy to your cluster. You can deploy them to Code Engine. You can deploy them wherever you want. I just want to show you how to get things set up and everything good to go. So what we're going to do here before that is you can expose your app, so you can test your application. You can add storage to your application. You can choose a storage solution. You can see how Kubernetes storage works. You can connect different integrations. So there's cluster logs, metrics, and audit events. And then you can install different managed add-ons and review the state of your add-ons as well. And then we have some troubleshooting tools as well. So basically, we have logged into our cluster in the Cloud Shell. And now we can deploy an application. We can do all kinds of stuff. So I have an application that I deployed. What's great is you can, well, here or here. So if we close this, we go to our Kubernetes dashboard. So I have this sample project here. Again, everything's in the slides as well. So I deployed this Kubernetes Bootcamp project. See my pod, my replica sets. It shows there's no CPU usage. We have some memory usage here. We have our pod, our default pod, and our default replica set. We also have our services here. So we have our Kubernetes service. We have our config maps and our secrets. And then we have our cluster role bindings and our cluster roles. Then we have our different namespaces. We only have one node here. And then we have our default service account. Now, what's nice is, we can get up and running quickly. We have a space to work that we don't need to have things installed locally. And then we have access to our Kubernetes dashboard where we can manage our CPU usage or memory usage or replica sets. We can run different jobs and pods. We have different service ingresses and services, our persistent volume claims. So we can do a lot of infrastructure pieces in a really easy way that are not going to be as manual as the infrastructure as a service pieces, right? So a lot of these things we can just set what we want them to be. Kubernetes, with orchestration, there's some auto scaling that goes on as well. You don't necessarily need to set policies like you saw with Cloud Foundry. Let me zoom out. Zoom in. That's good. So one thing I want to show you before we move on to our last piece here. So remember I mentioned before the IBM Cloud Kubernetes Service certification. So we have certification courses for Kubernetes on IBM Cloud. We have different labs here. So we have containers and Kubernetes essentials, scalable web applications. So each of these takes an hour. So it's not really something that we could do during this workshop, but these, I want to get you set up and get you started so that you can start working through these things. The labs have their own environment, so you don't necessarily need to do these things in Cloud Shell or anything. There'll be a containerized environment with a cluster set up for you, and when you finish the lab, it'll delete the cluster. But again, upon completion of the labs, you will be able to earn your IBM Cloud Kubernetes Service certification from completing these 3 labs, which is really nice. And then that last thing we're going to look at is OpenShift deployment. Go here, get rid of this. Okay, so I'm going to go back and take a look at, I'm just going to type in OpenShift, oops, Shift, Red Hat OpenShift on IBM Cloud Service. As you can see here, so there is not a free tier for Red Hat OpenShift. However, I do have for you Red Hat OpenShift clusters for you all to use for free. So this is the URL and OS Lab. So what you'll do here is you will go to this link, type in the key OS Lab, and this takes a little bit of time to provision as well. So you'll put in the lab key, your IBM ID, your account, and you'll click submit, and when it's done, it'll say congratulations, you've been assigned an OpenShift cluster. Log into this IBM Cloud account. So you should receive, if I'm not mistaken, you should receive an email to access the cluster. But just to show you, so we have OpenShift 4.6 orchestration service. It's default to classic infrastructure, but you can choose VPC or satellite, which I'm excited to start exploring more and playing around with satellite. So that will be coming soon. We have our default resource group. Our geography is North America. We have multi-zone availability. And then we have our worker zones. So we have worker zones in Dallas, 12, 13, and Dallas 10. Then we have our worker pool. So we have 4 CPUs. We have 16 gigs of memory, and this is the cost. what we can do here is we can take this down. So now we only have 3 worker nodes, as you can see here. So it started with 9. We have a multi-zone load balancer. So this is doing a lot of those infrastructure pieces that we've been looking at. OpenShift is doing a lot of the auto-scaling, orchestration, infrastructure pieces, multi-zone load balancing, right? So for instance, when we were looking at data centers or and we were designating, right, which data centers we wanted to choose. So what this does is this allows for multi-zone clusters to cross-zone load balance, right, with the scaling and orchestration. So we also have, let's see, we have a public endpoint. You can have private and public endpoints. There's an infrastructure permissions checker, and then we have our resource details. So this is our cluster name here. So I'm not going to create one, again, like I said, because you already have access to a cluster. So again, this is the URL and the key that I have for all of you. I think you have access to it for like 24 or 48 hours. So if you want to do anything with the OpenShift in the next 24 to 48 hours, this is your key to do that. And again, Upkar and I are always hanging out in the Call for Code workspace. So if you have any questions, you can always reach out to us. One thing I would like to show you, that doesn't require access to your own clusters, that you can do at any time, are the Red Hat OpenShift on IBM Cloud with Open Labs. So we have, again, just like with the Kubernetes, IBM Cloud Kubernetes as a service, we have labs here. So we have OpenShift on IBM Cloud Part 1, Part 2. We have application security with App ID. We have a bring your own app to Red Hat OpenShift on IBM Cloud. So if you have an application that you want to get up and running, you know, there's a lab for that. So again, these are all free to use. The labs, again, will spin up their own environment. But if you would like to get your hands dirty and really play around with some Red Hat OpenShift stuff on your own outside of the lab, like for instance, when you finish the lab, everything shuts down, right? And the cluster gets deleted. If you want to access the lab, play around with it, see what you know, different features and things are going on. We have some OpenShift tutorials as well that you can work through, that are, you know, free to work through, that you can use these clusters to work through, and they're not going to just disappear immediately when you finish. So you'll have access to that for 24 to 48 hours. Sorry, let me just here. Here we go. Okay. So oh, there we go. Okay. So some pros to platform as a service. And again, we're referring to Cloud Foundry, IBM Cloud Kubernetes as a service, and Red Hat OpenShift on IBM Cloud. So these are all of our platform as a service offerings at IBM. So some of the benefits of our platform as a service offerings, platform as a service in general, it's faster time to market. So with platform as a service, there's no need to purchase and install any hardware or software that you'll use to build and maintain your application development platform. And there's no need for development teams to wait while you do this. So you'll simply tap into the cloud service provider's platform as a service resources, like you saw, and then just begin developing immediately. So for instance, you're ready to, if you have any images, you're ready to go with Kubernetes. Again, it takes a little bit, IBM Cloud Kubernetes as a service, it takes a little bit to spin up. OpenShift takes a little bit to spin up as well. But once you get them spun up, you're ready to go. And you have a lot of portability and flexibility in your solution and the infrastructure for your solution. So it's faster, easier, it's less risky adoption for a wide range of resources. So platform as a service platforms typically include access to a greater variety of choices up and down the application development stack. So that includes operating systems, middleware, databases, and tools such as code libraries and app components that you can affordably and practically maintain on premises, right? Because you don't need to worry about all of the hardware and things being compatible, dependencies. It also lets you test new operating systems, languages, and tools without any risk. So for instance, you don't have to invest in the infrastructure required to run them. So if you want to try something out and it doesn't work for you, you didn't purchase all of this, hardware and software and provisioning and resources to do that. You can easily try it. If it doesn't work, you're not out all of the infrastructure pieces to try out a new operating system or language. It's easy and cost effective to scale. So if an application is developed and hosted on premises, starts getting more traffic, like when we talked about, like all of a sudden you just get a huge surge in traffic to your application. You'll need to purchase more computing, storage, and even network hardware to meet your demand. If you're hosting on premises, remember, like what we talked about, like you're hosting things on premises with your own servers and databases. So you're not able to do that necessarily quick enough, and it can be wasteful. So you typically purchase more than what you need. But with platform as a service, you can scale on demand by purchasing just the amount of additional capacity you need and not having to worry about any of the hardware pieces. And it's a lot lower cost because there's no infrastructure to build. Your upfront costs are much lower. And more predictable because platform as a service provider charge customers based on usage, right? So you're only getting charged based on what you use. So the last thing we're going to look at here, which as you'll see is going to solve a lot of the issues, some of the pain points that we've seen and looked at. So the last model we have here is function as a service. So our IBM function as a service offerings are IBM Cloud Functions, IBM Cloudant, and IBM Cloud Code Engine. So function as a service is a type of cloud computing service that allows you to execute code in response to events. So as you get requests coming in, without any of the complex infrastructure that's typically associated with building and launching microservice applications. So if you're looking to break down a monolith into microservices and get things, scalable and, running seamlessly and getting things, executing code quickly and getting things up to speed, serverless or function as a service is a really great option. For breaking everything down into microservice applications. So hosting a software application on the internet typically requires provisioning and managing a virtual or physical server, where we saw like way in the beginning, like we talked about, right? Like all of that required a lot of knowledge and manual process. But as a developer, we don't need to worry about any of those pieces. With function as a service, the physical hardware, virtual machine operating system, and the web server software management are all handled automatically by your cloud service provider. So this is going to allow you to focus solely on the individual functions in your application. So serverless and functions as a service, just to kind of make it a little less ambiguous. They're often confused with each other, but the truth is that function as a service is actually a subset of serverless. So within the serverless umbrella, we have functions as a service. Serverless is focused on any service category, whether it's compute, storage, database, messaging, API gateways, where configuration, management, and billing of servers are invisible to the end user. So function as a service, on the other hand, which is the most central technology in serverless architectures, it's focused on the event-driven computing within application code, containers, and it's only run in response to events or requests. So I'm going to show you an example. So I'm going to go here, I'm going to come back out here, and I'm going to search for code engine. So as you can see here, we have run your application, job, or container. So we can run applications, jobs, and containers on a managed serverless platform. It's going to auto-scale workloads, and you're only going to pay for the resources you consume. So again, you do need to upgrade to a pay-as-you-go account. But again, there's a light tier here that allows for quite a bit of CPU memory and allows for a lot of incoming requests. Okay, so what we're going to do, the first thing we're going to do is we're just going to run a container from an image. So as you can see here, what's really nice is we have these examples here. So we already have a Docker image here. So I just want to show you how quick and easy this is. So we already have an image, right? So I'm going to click Start Creating. Again, we can create new applications and new jobs. We're just going to create a new application. It already gives it a name. I'm going to just say Code Engine Cloud. Okay. Now, as you can see here, we need to select a project. I don't have one yet, but I can create one. So I'm going to click Create a Project. Oops. Now, the best default is this Frankfurt region for some reason. It's usually usually what we default to. So go ahead and click Default, name your project. I'm just going to name it my name. Already has a resource group default. Create. So it's going to create a project here. Done. That was easy. It's already selected. Then, as you can see, choose the code to run. So we're going to just use this image reference here for this sample code that we have. We can also choose source code. The listening port is 8080. What's really nice is you can change this. So if you have requests arrive at, if your code is listening for incoming requests at another port, you can change this. So standard ports are 80 and 443, and they're mapped to the port specified here. So the default is 8080, but you can change it to, whatever, wherever you're listening for requests. So keep this 8080. Okay. So we have all of this here. We have our project created. We have our container image. So we didn't have to do a whole lot. We just gave it a name, gave it an image, a container image. There's a lot of sample code and pre-made container images available in the Code Engine repo, which is in the slides as well. As you can see, it's deploying. and it's ready. So that was like, you know, at least half the time of our Cloud Foundry application. That was our quickest get to the development piece. You know, let's get to developing that we had seen. So here's just some sample code. Got some information. We have our Kubernetes port, TCP, service host. Here's our stuff. So here's our little sample application. So it's up and running. So we were able to do that, you know, in, you know, less than a minute. What's really nice here is we also have our, like for instance, let's say I wanted to, you know, change, let's say I wanted to update to a version 2. I could just do that here and then save it and deploy it, and then I would have, you know, my 2 versions. The other thing we can do is, I go back to Code Engine, start with source code. So with a really fantastic feature of Code Engine is source to image. So you can take a repository of an application, and Code Engine will create a container image for you to deploy, right? So this is source code, right? And this is serverless function as a service deployment, right? So essentially we need to take a container image and run it as a container. And we're able to do that from just source code. So I'm going to just say source code app. So again, we have our project here. We only need to create one. You know, we can talk later about some best practices for organizing projects. Here's the source code, right? Here's our listening port. Let's see. Select project. Okay. So we're going to click specify the build details. We have our code repo, right? So this is, it can be private or public. So we have code repo access public, and then we can specify the branch name. So let's say you have everything deployed off, you know, some, you know, v2.6, right? Let's say that's the version of your application that you're deployed on, and that's the branch that you're using. You can specify that here. You can change this. Or let's say you're, you know, so we just need to make sure, okay, that's set up. We have our strategy. We have our Docker file, okay. All right, and then we have a registry server. So all this is automated for me here. Done. So I can update my registry. So this is updating some things, creating it. So it's created a new namespace. I think maybe because I switched the location. That's okay. So we have, you know, I didn't need to do anything except click through and just confirm. So here's the image reference, our registry access, the source code, the branch. So let's say you have code you want to deploy that's within your project, like it's on your main branch, but it's like within, you know, your app folder or your, you know, something. You can specify where it is, and it will do that for you. So you have one application and one image build. You can click create. And we're done. So it's checking the image build here. So what it's doing, it's taking that source code that we gave it. Again, we're just using the sample source code here. It's using the source to image to build a container image from that source code, and then it's going to deploy it to Code Engine as a container. And then we'll be able to see it there. So just refresh this here. Okay. Now for some reason, I think that's just a bug. Yeah. Okay. I just needed to refresh it. I'm not really sure. I think it's probably my internet stuff has been running slow. So we have our application. It's ready real quick. I didn't have to do anything except, you know, click a few buttons. Just make sure, like, hey, is main where your application is that you want to run. Then we can open our application URL. And again, here's the same application that we just deployed to Code Engine quickly, except this was from the source code. So this was from the source code. This was from the container image. As you can see here. So here's my Code Engine Cloud, and then here, so source code app, right? Both deployed real quick. One thing I want to show you that's really cool. So remember when we were talking about Cloud Foundry with the auto scaling? So auto scaling is built into Code Engine. So what's really fantastic is that you can auto scale all the way down to 0. So if you're not getting any traffic to your application, you can auto scale all the way down to 0. So you're not spending any money on provisioning that you don't need. So it's only spinning up instances when you get requests. You can also set a maximum number of instances, you know, so that your application can't get spammed or scraped, or, you know, have requests just over and over again hitting it. You can define the amount of CPU and memory resources for each of those instances, and then requests. So this is really cool. So this is the maximum number of concurrent requests per instance, and it can range anywhere from 1 to 1,000. And then you can request the timeout as well. A feature that is coming soon, as you can see here, we have traffic. So let's say you have, you know, multiple, and I have a, excuse me, actually I have a better example in the slides. Let me show you that. Here we go. And again, you can follow with the slides too and deploy a health insurance application too. But as you can see here, I have a V2 of the application, 2 instances, and what we can do is, oops, where did it go? Here we go, revisions and traffic. So as you can see here, we have traffic, right? I have 2 versions of V1 and V2 of this application. So I have 2 container images that I deployed of this application. What is coming soon, which as soon as it's available, I'll share with you, is that you will be able to manage your revisions and traffic. So, you know, if you need to do A/B testing, you can direct 50% of your traffic to one, 50% of your traffic to another. It shows you which one's the latest. If you have multiple versions, you can delineate traffic. You know, you want to put 25% here, 50% here, you know, 15% somewhere else. You're going to be able to customize your revisions and traffic and really designate what amount of your incoming requests you want to direct to the various revisions you have of your application, the different versions of your application. So this is going to be really fantastic. I'm excited for this. It's coming very soon. I have all kinds of stuff here too. I have a lot more in here than we have time to go over. But what Code Engine can do, so it can create container images from source code. It can access source code in repositories. So it can push images to registries. It's integrated into IBM Cloud and all of the IBM Cloud services. It handles and hides all the cluster provisioning. So remember all that stuff we saw with the IBM Cloud Kubernetes as a service. It handles all of that and hides it all. So you don't need to worry about it. You can just worry about development. And it handles all of your provisioning, configuring, auto scaling, and all of your managed servers. It auto scales workloads up and down or to 0 when no requests are active. And it's built on open source Kubernetes, Knative, Istio, and Tekton, which keeps all of your applications and jobs super portable. So function as a service pros, you're able to focus more on code, not on infrastructure. You are paying, oh, you know what? Let me reshare. Just a second. So that you can, glad I checked. Didn't want to get you guys lost. All right, let me reshare this real quick. There we go. Focus more on, with functions as a service and serverless, you can focus more on your code, not on the infrastructure. Pay only for the resources you actually use. Auto scale up or down, typo, even to 0. And you can get all of the same benefits of robust cloud infrastructure. Man, typos. Robust cloud infrastructure. So we have, let me just see here. Okay, so we have a few call for code use cases here. Let me see. Let's see. Oh, okay. Let me okay, so we have some call for code use cases here. I'll just briefly go over them with you. So we have a lot of really cool call for code projects focused on natural disasters, climate change, racial injustice. So as you can see here in 2018, we have a Project OWL solution. And actually deployment is underway in Barcelona, Spain, Australia, and Puerto Rico. So do you remember the big earthquakes that were in Puerto Rico? And so they actually went in and set up what they call cluster duct protocol. So it's using radio to extend service to places that don't normally get service. We have a deployed solution Prometeo. So this, we have an example of the infrastructure, or I'm sorry, the architecture for Agrali. So these are all call for code solutions that not only won the $200,000 prize, they also have been working with IBM call for code teams to implement their solutions. So for instance, Project OWL is being used in Spain, Australia, and Puerto Rico. Like they're actually using them to, help people in natural disaster. It's deployed. Prometeo is in Argentina, Australia, and some more countries as well. So we have some of the information. So right now, the IBM Service Core team of hardware, software, data science, and user experience experts are improving the Prometeo platform solution to a V3, and they're actually field testing it with Samsung equipment in 2021, so this year. It's an open source project. and they're bringing their solution to the Linux Foundation as Pura, and they're inviting an expanded community of developers to improve it and extend it to new locations. So these are things that are deployed. They're open source, which means you can contribute to them and make them better, you know, be part of the team. So, and what it is Prometeo allows firefighters to wear a small device that measures key variables like temperature, humidity, and smoke concentration, and then it sends it to IBM Cloud for analysis. So what it's doing is it's using IBM Artificial Intelligence, Internet of Things, and Kubernetes to monitor the safety of firefighters when responding to natural disasters. Now we have an example of, we have an example of the infrastructure here. I'm sorry, the architecture here. So here's the devices. So, and it's using all, you know, IBM products and services. So it's using App ID, Internet of Things platform, Python, has MariaDB pods, Node client, Node and Python dashboard. We have a Node WebSocket server here, all on IBM Cloud, and we have our, this is all within our Kubernetes cluster. And then call for code legit info. So this is another example of, you know, all of the things that we've touched on, different deployment models. So this is the architecture for legit info. I know we're starting to run out of time, but I just want to say thank you all so much for coming. If you all would be so kind, I have a survey here. Let me get it for you. Also, feel free to ask questions. You know, I have time to answer any questions you have. So let me post this for you first in the chat. There we go. Let's see, we have some questions. Do we have an IBM Sandbox to try out? Yes. Okay, yes. So it looks like this was a little. Okay. Okay. Let's see here. Okay. So if you have any questions, again, feel free to. It's a quick two question survey. You don't have to provide your name. It doesn't, you know, require you to add any sensitive information. It's just you know, quick thing. I think we might have had some. Deploying on Node. Let's see. Okay. So I just want to make sure you all were able to, see, you know, the the code engine deployment. Was there anything that you weren't able to see because things may have frozen? I just want to make sure. Again, everything is available in the slides as well. But I just want to check with you all too to see if there were any pieces that that weren't working for some reason. Feel free to, you know, add to the chat. I hope that, yeah, so these sessions are recorded. see, presentation slides. So let me just post those at the end again for you. And like I said, if you have any questions, feel free to post in the chat. May have had something frozen at some point in time. But I'll hang out here for a few minutes to answer any questions. And if there's anything else you guys need, or if something froze and you weren't able to see it, go ahead and post it in the chat. And I can answer any questions that you have for the next few minutes too. So I'm going to play a little music, and I'm going to hang out to answer any questions you guys have. So feel free.